look a lot like queuing, but it's not nowhere near the same thing. And promises are really big on the front end, especially in the JavaScript world, because you can write fire and forget code. And it's a little easier in JavaScript because JavaScript is still synchronous, but it's non-blocking synchronous. And PHP hasn't got there yet for most things. On the front end, a great use of this that I've seen is like if I've got a widget on my website that tracks Twitter, PHP or hashtag PHP on Twitter. Okay, once every 2 minutes, I can create a promise that goes out and hits the Twitter API and brings back the new feed, and then I can update it all in the background. I don't have to tell the user, hang on just a second, let me go do this. And then when I get back, then I can tell them, okay, now you can keep going. But promises are useful on the back end as well. This all started with a problem. I have a client that I do some training and advising for on a every other week, and I was talking with their development team, and I said, okay, what's the biggest problem you got? And they said, well, we've got a client that has 2 WordPress installs. One that is their back of house management system, and the other is on the front end, and it's optimized for speed. So they build everything, they build all their posts and everything on the back end and click a button and it uploads them. It's not really terribly difficult. There are WordPress plugins that'll do this, or you could write your own with the WordPress REST API. But the problem with this particular setup was every story they had 30 to 50 images in it. Now, this can take forever to upload. So we started brainstorming and started looking around at what was available. And this talk really came out of the results of the experimenting that we did. Now, this is not all just slide work. I've got some demos that I'm going to show you some little later on in the program. Promises, like a lot of stuff, come to us from JavaScript. The promises that we're going to be looking at tonight are the Guzzle HTTP Promise library, and that's an implementation in PHP of the Promises A+ library. Promises A+ is the prominent one in JavaScript, the prominent pattern in JavaScript. So while the code is not usable between JavaScript and PHP, the concepts should transfer fairly easily from JavaScript to PHP and back. Promises at their core give us a wrapper for really what we always had. Since the early days of Ajax, I mean, back when the letters actually meant something, asynchronous JavaScript and XML, we've had methods like success and error. But promises expand beyond that and give us the then method. And they like to call promises thenable because not only does then wrap up success and error, but then methods are chainable. So you can have multiple then methods. You can have this, do this, then do that, then do this. So it's really an elegant solution to a problem that a lot of developers face. Promises also bring this concept out of just calls to back-end servers. Now, any piece of code, even in PHP, can be wrapped up in a promise, and it's a way of transporting that piece of code and the results, the result for a success and the result for an error all along. You can pass that, once you've created the object, you can pass it around until you're ready to resolve it, and then you can resolve it. Now, this is the official definition. Every talk, no talk is complete without a Webster's Dictionary defines, but this is from the Promises A+ homepage. It says a promise represents the eventual result of an asynchronous operation. Now, that's mostly true, but like I said, not all promises are asynchronous. You can actually run promises synchronously. Not much of a point to it, but you really can do it. I'm going to show you one that we're going to run synchronously in a little bit. Thinking synchronously really takes a lot more thinking asynchronous takes a lot more forethought when you're building stuff like that. So while promises are best in an async world, you don't lose all the value if you are running them synchronously. Thenable. I talked to you about that. A thenable, we have a method called then. And instead of in the original Ajax implementation, and these days in jQuery, you've got success and you've got error, I think they're called, methods, and you usually either hand them a callable or you write a you write a method just right in there. And that's how we used to do it. With Thenable, we modify that. Then takes two parameters. One is, and both of them are callables. One is the success and one is the error. And these can be, you can pre-package a function in a variable and just hand the variable, or you can code the function right there in the then clause. It makes no difference how you do it, as long as they're valid asynchronous, or I'm sorry, valid thenable, or valid functions, anonymous functions. That's what I'm looking for. And valid closures. Here's what one looks like. And this is a PHP promise. I use my library, my promise library, and then I create a new promise. And then I say, for my then clause, I'm handing it two things. Now, the first thing is on fulfilled or success. And fulfilled is the official term, fulfilled and rejected. And I hand it a value. Now, it will only hand in one value. Guzzle PHP promises will only hand in one value. We'll talk about that, and I'll show you an example of how I get around that when we get to the code demonstration. But it's just an anonymous function, and all it does is say this promise was fulfilled. And on rejected, I do the same thing. This promise was rejected. The fun thing about Guzzle promises is rejected also throws an exception. So unless you want to handle that exception somewhere else in your code, you got to wrap the calls or the calls to the promise in try catches so you can catch that. Now, here's the same thing basically in a JavaScript promise. We have a call to slide by. This is actually a piece of code that I wrote. Believe it or not, I write JavaScript every now and then. But we have a call to slidebot API, and that's a new promise. And this is jQuery, and I'm doing a get call to an API. And then down here, I define my then. And my then is, again, two anonymous functions that each take a value. Oh, hey, that should be reason. But I'm just console logging out. No matter what happens, I'm just console logging out what it hands me back. This was just to test out some code that I was writing in another project. But that's what it looks like in PHP and in JavaScript. And as you can see, they're very similar. Now, Ajax and its predecessor, the XML HTTP request object, were not really easy to work with, okay? It was very, especially with the XML HTTP request object, it was very easy to get things wrong. And this was in IE6. Microsoft put this object, that was the first time I'd ever seen it. And you really only had one method that you cared about, and that was on ready state change. Okay, no success, no failure, no then. It was on ready state change, and this was called every time the state of the object was changed. Well, the state of the object changed a lot. Okay, and we really only cared about state number 4, which was this is the results of your call to a API. So we had a lot of if-then statements or switch statements and stuff like that inside our on-ready state change to deal with how to handle all the other state changes. But we wanted to make sure that the state change, the state number 4, was the one that was really important to us, because even if it was a failure, that was the one that came back. Once we got a 4, we had to figure out, okay, was this a success or a failure? We had to check the HTTP status code and all this kind of stuff. It was not really easy. Okay, now we have a then method, and it is so much easier. Now, there are PHP frameworks out there like React PHP, which is native or is userland code, that implement promises. Matter of fact, React takes a third method which is status. That's not the name of it, but it basically, if you've got a status bar and you want to increment the status bar, you can call this method to update the status as your process is running. React is just regular userland code. There's also classes, or there's also frameworks like Swool, which are extensions that you compile into PHP. Now, those actually operate a lot faster and with a lot more stability because they're compiled into the language itself. Everything happens at the engine level, and we're going to talk about why that's important in a little bit. What we're going to talk about are guzzle promises. And if you've ever used guzzle, then you actually have promises loaded because guzzle uses them on their backend to make their calls. But if you've never used guzzle promises directly, you can start taking advantage of them. If you're making a call and you use guzzle post async or get async or something like that, then guzzle takes advantage of an old trick that uses curl, and curl can fake async. So you can actually make 2 or 3 calls out to a website API, websites or APIs, and it looked like it's operating asynchronously. Matter of fact, back in PHP 4 days when we first got curl, Wes Furlong, the guy that wrote the mail function and wrote PDO, he actually wrote an article on how you could fake threading using the curl API to kind of fake things and make it look like your PHP was doing multi-threaded stuff. Still, even with all this though, guzzle HTTP promises they're single-threaded because PHP is single-threaded, but they implement the same spec as JavaScript, so we get the same interface. Now, we do have threads in PHP on Linux. Threads are not the same thing as asynchronous. Threads are separate processes that we fork off and that go off and do things. Now, this sounds like asynchronous, but it's really not. And promises are much easier to work with than threads because they remain inside the same process. And you're going to hear me talk a lot about how JavaScript is non-blocking synchronous. Well, PHP is blocking synchronous. It can only do one thing at a time. And when it finishes that, then it can go on and do something else. Whereas JavaScript doesn't have that problem. So it can do multiple things in that main thread, but it's still only got one thread. If you're into threads, you can check out the pthreads library. You can load it with Peckle. They're useful. I've used them to write some stuff, but quite honestly, there's a lot of overhead and a lot of mental gymnastics that developers have to do to keep everything straight. They're not the same thing as async processing. Okay, so a process is a piece of code that executes separately from your main happy path. And you can't see me, but I'm doing the quotey fingers. If a promise is run asynchronously, then it shares the processor with the main code and path, and it just swaps back and forth between them. You pay a penalty every time you swap. So this is not always the fastest way to do things. Remember, I told you that stuff done in the engine asynchronous done in the engine was faster than asynchronous done in userland code. That's because the engine can swap tasks faster than we can, or swap context. Something that nothing else, promises are a great way to handle an atomic unit of work. An atomic unit of work is something that nothing else depends on. Okay, and it depends on nothing else. It has everything it needs to accomplish its task. For instance, if you're writing something to the database, that'd be a great promise, okay, because you can wrap up the username and the server name and the database name and the password and everything that PHP needs to connect to that database, write the record, and then come back to you and tell you if it succeeded or failed. It's a great way to, or it's a great task for a logical unit of work. writing out to log files, sending emails. These are all great things that are great for potentially wrapping in Promise. When you send an email from your application, there's really no need to wait till the mail function comes back and says, hey, yes, it's sent. If your application's coded correctly, if there was something that went wrong, you could notify the user or post something in the log file and just keep moving. The caveat here, though, is that if you have a mailing list of 1,000 emails that you have to send out and you want to use async promises to do it, you're basically going to shut down most servers at that point. Because remember, PHP has one thread that's running. Well, when you queue up or you create 1,000 promises, asynchronous promises, and then say, go do it, as we'll see in just a minute. Well, now you have 1,001 tasks that have to swap in and out of that main thread. This is going to shut everything down. That is not a good use of promises. We'll talk near the end about different ways that you can get around that, but there's no good ways to get around that. There are better ways to send out 1,000 emails at one time. Now, here's the other thing, is your code has to be able to operate when events come in out of order. There is no guarantee that an asynchronous promise will execute in any specific order. In the case of sending emails, some servers may respond faster than others. Thus, those promises get resolved faster. I mean, if you create 10 promises to send 10 emails asynchronously, you're not going to be guaranteed that they're all going to come back in the same order you sent them. And we're going to show, the demo I'm going to show you is uploading files. And usually if I upload 10 or more, then some of them are going to come back out of order. So the closure, yep, okay. Did not change. There we go. Oh, finally, with asynchronous promises, you got to have an event loop, okay? If you create 10 promises that each are going to take 10 seconds, and then simply your PHP script simply comes to an end, those 10 promises get garbage collected like every other process and variable in PHP. You've got to wait until they're done. You got to have some kind of mechanism to wait until they're all done and have all been resolved or rejected before ending. Thankfully, Guzzle gives us just such a tool. Okay, demo time. Let me do one thing here real quick. I have to open a browser up and I have to look at my config file, and I don't want to do that while I'm sharing with everybody. So let's do that. I'm sorry, I usually have this one already loaded. Okay, stop sharing that screen. And let's start sharing. Oh, that's interesting. Okay. Let's start sharing this screen. If I can find the share screen. And I want to share this screen for a while now. I'm hoping that's working. My browser has really freaked out, and there's a lot of angles and triangles and stuff. Josh, can you see that? Can you see my browser up there now?
Yeah, I'm seeing a browser, yeah, like a WordPress.
Yep, that's it. Okay. Let's take a look. Let's see what kind of state I left this in. Okay, it's in a solid state. This is test.calevins.com. It's where I use to test a bunch of different stuff. It's actually on my development server. And the last thing I was testing here was selfies with Cal. And if you've ever seen me at a conference in the last year or so, you know I take pictures and it puts in these nice little frames and it uploads them and it tweets them out and it's all good fun. This is the system I use to test all this stuff with. But we're going to use this just to upload some raw pictures, and we're not trying to show anything other than asynchronous uploading and downloading. But I can do that with using the JavaScript or the WordPress API. So I've got a Symfony console here, And if you've ever worked with the Symphony concept, that's my absolute favorite thing to work with. Then most of this is, if you've worked with it, then most of this is going to look familiar. If you haven't, then this config function, this is just what Symphony console component calls to configure itself, and it has to be there. And these are the options that we can pass in, whether we want to do this asynchronously, synchronously, and how many we want to do. And then execute is where all the magic happens. Okay. Now, I'm not going to go too far into this other than to say that all it does is fire up either an asynchronous uploader or a synchronous uploader. Let's get the synchronous because we're going to do that one first. Yeah. Okay. So it does it either asynchronously or synchronously, and it will upload X number of files to my server that I just showed you. So while I'm talking, let me do this. Console. I forgot the command. What is it? Oh, upload. Okay. Upload. And let's do this synchronously, and we're going to do 10. Now, I'm hoping everybody can see this, mainly because you're sitting there in front of your screen. So, it should not be a problem like if we're at a conference and you can't see my screen. So we're going to upload 10 images synchronously. And that it's about as exciting as you'd think it is. Anyhow, while it's uploading, let me walk you through what is happening. I've got a for each loop here, okay, and it goes and it gets a list of files, and those files are over here in the data directory, and I've just got about 40 or 50 files over there. We're only going to upload 10, but it goes and it gets that list of files, and then it goes through each one of them and uploads it, and it uses just the Guzzle client, and it posts it. And I've got everything here, including my bearer token that I get from from WordPress. And then, as long as we get back a 202 or 201, then everything's hunky dory. We got it right. If we don't get back a 201, then it's going to throw us an exception. Otherwise, it's going to decode the picture and hand it back out. Or decode the payload and hand it back out. This should not be taking that long. I've got good bandwidth here, but we're going to keep talking about that. Over here, oh, there we go. Okay, now it uploaded 10 files. Took 71 seconds, so 7.17 seconds per upload. Now let's go back over here. And we can see we got 10 new files. Okay. There's my good buddy, Paul. That's Olivia Bissett. Her father runs the WordPress Miami, or WordPress, WordCamp Miami and the WordPress Miami user group. And this lovely lady was our tour guide in Sofia. So, but I wanted to get a picture with her because that was a fun time. Anyhow, the point is we got 10 pictures. Now, while I am continuing to talk, let's go console. Oh, hang on. Okay, let's go console clean. That's just going to remove those files because the next time, if I don't remove them, the next time it tries to upload them, it'll start erroring out because they already exist on there. But anyhow, it took 7 seconds to upload each file synchronously. Now, let's do the same thing. Now, before I tell you this, these are actually sent. Let's do -v. These are actually sent in alphabetical order. So when they come back, if they don't come, or when it says it's finished uploading, if they don't come back in alphabetical order, then it will show us that this was asynchronous. Usually with 10 files, I get 1 or 2 that are not in alphabetical order. One last time, let's go over here. Yep, okay, we're clean, we're ready to go. While that's running, let's look at what we're doing right here. Okay, notice it says we're starting the event loop. We've already queued up all the promises. Everything's happening at this point. Now, I've still got my files directory, or my for each that is my 10 file names that I'm uploading. I do an fopen to get a handle, and I just call that file. But now I do a client request async, and I'm doing a post, and the body is the handle of that file, okay? And then I give it the file name. That is my promise. I call that this promise. And then I create my then. On fulfilled, I want it to just say this was uploaded. On rejected, I want it just to say this promise was rejected, okay? I don't keep track of which ones were rejected. Oh, hey, there we go. Okay, as you can see, they're coming back out of order. Paul came back first, then Georgie, then Martin, then Olivia, then the tour guide. You can see that they did not come back in the same alphabetical order that they were sent. More importantly, it only took 5.3 seconds for them to upload because talking to servers were using that little curl trick, and so it does fake async very cool. That's really the heart of it, okay? As you can see, I did that. Oh, remember I told you have to have a wait loop? Here we go. I'm creating an array called promises, and each time I finish creating a promise, I give it to promise. But we've not actually talked to the server at this point. I've just created the promise. We have to call the wait to before it will actually talk to the server. Well, Guzzle gives us a method that's not in a class. It's just a function called all. And we call all, and I hand it the array, and it gives me back an object of all the promises. And I can call wait on that one. Now, in reality, if you read the code, all it's doing is sitting there and going, for each one of these promises in the array, go through, is it done, is it done, is it done, is it done, is it done? Nope, okay, sleep for a second, go, keeps doing that until until all the promises have either been resolved or rejected. But that's built into it. That is our event loop. And remember I said, notice it started our starting our event loop. That's right here. So this whole for each loop, instead of having to upload each file individually and wait on all that, it did all of that in the first second and then went right to starting our event loop. And that's where we spent most of our time, was right here in this wait. Okay, I do, no, we're not gonna clean this. I'll clean it later. I do have one more. That shows you the usefulness of using it to talk to other servers, talk to APIs. And that's what Guzzle uses it most for. And most of the demos that you'll see on Guzzle Promises, that's all it does. But promises, like I said, are a way of encapsulating a logical unit of work. You don't have to do that logical unit of work right then or even asynchronously. You can just wrap up a bunch of logical units of work and use them as needed. I have what I call Schrodinger's coin, okay? We're gonna flip 10 coins. This is another command, and my one parameter is count, so I can tell it how many I want to flip. We're going to flip 10 because they fit here on the screen. What we're going to do is I'm going to create like last time. I got a for loop here. It's going to count up, and I create a new promise, but this time I have an anonymous function here in the creation, and this is what's called my wait. Okay, now I'm not passing in any parameters, but I am using several things. I'm using the loop counter variable. I'm using this promise. I'm passing a reference into that, and that's this. Okay, so it's a bit goofy, but I'm passing a reference of the promise I'm creating into the promise that I'm creating. And output comes from Symphony command, and it just gives us an easy way to notify things, to notify the screen that things are happening, or notify the user that things are happening. Like we use it right after here, and we'll say flipping, and we'll tell it which coin. Now these are going to operate synchronously because I'm about to, after I create them all, and then give them my then, and my success is basically I flip the coin here when I call the wait, and if it's tails, then we resolve it. That's success. If it's not tails, which would of course means it's heads, I reject it. Remember I told you can only pass one parameter in? Well, I needed two. I needed to pass the coin in, but I also needed to pass in the output so I can notify the user. So I just put them in an array and pull them out of the array in the anonymous functions, because it will only pass one parameter in. So I got my my then that here, and this is my success function. It takes one parameter. Parameter one is the output, and I say write we accept, and parameter 0 is going to be the coin. The coin's either going to be heads or tails. And my reject is basically this is going to happen if it's tails. Reject is going to happen if it's heads. I add it to my promises array just like last time. Now, I can do this, and I can put my promises array in my DI container, and it can sit there. And whenever I need a coin, I can just pop one off the array. Okay, I can do a array slice, pull one off. I've got my promise. I've still got 9 more on there, and I can flip a coin at that time because I've already got them set up and ready to go. I don't have to use them immediately. I don't have to use them all at the same time. I'm not going to do that, though. I'm just going to put them in a loop. Right here, we call the wait. That calls this method right here. That's going to flip the coin for us. And when it flips, it's either going to output we accept or we reject. But promises, when they're rejected, throw a rejection exception. I want this loop to just continue. So I catch it, but I don't do anything in the catch. I always put the no op in there so that people don't think that I just forgot to put something in there. This is, I know something's supposed to go in there. I just didn't bother with it. And then for some reason, since I began programming, when I'm writing a command line script, the last thing I do is always output done. And you can see it here, and you can see it there. So let's flip some coins. Did I do it again? I did. Okay. Nope. Console flip 10. 10. Okay, you ready? This is where everybody goes, ooh, ah. No, I basically delivered exactly what I told you, okay? We're flipping 1, and that's in our wait. And then we call it, and it says, okay, we reject heads. Oh, we accept tails. It just goes through it. Again, I put these in a loop just to demonstrate them, but you could have put them in your dependency injection container, popped them off as you needed coins to be flipped, popped them off as you needed emails to be sent. You could queue up, you could create several of these and just be able to pop them off, hand them the email and say, go send it. Database writes, anything like that. You can use this and it will hold everything, hold that logical unit of work until you're ready to resolve it. And you're either going to resolve it or you're going to reject it. Okay. Let me stop sharing this screen. Let me see if I can share. I think I'm having to. Okay. I'm going to hope that y'all can see my demo time again. Let's wrap this up. Back to the problem we were trying to solve. Now, we've talked about this. Unless you're using pthreads or one of the async extensions, PHP is not yet multi-threaded. That's why we didn't get a huge bump in the upload speeds, but we did get a bump. Now, I've got way more bandwidth than we were using there. I could have done 50 of these without any problem. The bottleneck is PHP only has that single thread. And so task switching is what is taking so much time. Now, previously, I talked about a scenario where you could create 1,000 promises to send 1,000 emails. And as I said, this will kill your server, okay? Unless you've just got a bow-honking server, it's going to knock it right out of the park. One of the possible answers to this is a promise marshaller, okay? Now, a marshaller is just a piece of code where you queue up 1,000 emails, but instead of putting it in an event loop that says wait on all of these, you call wait on the first 10. And then you keep polling those first 10 until one of them has completed. And then you put another one in that group and call wait on it. And you keep going and going like that. And that's what we call a marshaller, and it will solve that problem. Now, 10 is an arbitrary number. You could adjust that to see the best size for your application. The problem with a promise marshaller is it just adds complexity to your overall solution. It will keep you from killing the server because it allows you to throttle the overall number of processes, but it has to be able to be called multiple times at the same time. It's at the same time as one promise might end while the marshaller is queuing up another one. It's really not as easy as it sounds to build one that works properly. Well, what about PHP 8? Actually, 8.1. It has been suggested that in the PHP 8 cycle, most likely in PHP 8.1, we will get some kind of asynchronous processing or non-blocking synchronous like JavaScript has in the engine. It looks like, crack Joe Selko? No, not Joe Selko. Joe Watkins, that's it. It looks like Joe Watkins' solution is going to be the one that wins out, and Joe Watkins is his solution is another implementation of promises, but it's promises in the engine. You can go out to the RFCs, the RFC website, and you can take a look at it. It's already up there. They're already talking about it. I think there's actually even reference implementation code that he's put up there on how to build this in the engine. But at that point, a lot of these problems go away, and we get a huge performance increase because the task switching is at the engine level, not in user land. Queuing. A lot of people think, oh, promises are the solution, when really what they want is a queue. Okay, whether it's a Beanstalk or a RabbitMQ or any of those type queuing systems, you still package things up as a logical unit of work, but you hand it off to another process. And you can, depending on how you set it up, I had one Beanstalk implementation where we had 2 tubes, and we could drop jobs into those tubes. And one tube was to be handled synchronously as they go in. The other tube was just as workers could pull them off. And we would have anywhere between 400 and 800 queue runners. And those are just tasks that pop something off the queue and go do the logical unit of work and then destroy themselves and set up the next logical unit of work. So everything's isolated. There's no leftovers between the queue runners. But that can get things going a lot faster. And if you've got 1,000 emails to send, if you've got something like Beanstalk or RabbitMQ set up with 100 queue runners set up, and you dump 1,000 emails into that pipe, or that tube, then those queue runners are going to make short order of getting all of those sent out. That's a much better solution than if you if you're trying to do it yourself. Also, you can have queue runners running on multiple machines. So your pipe might be running on one machine with maybe 100 queue runners running on that machine, but that might be all that machine can handle. But you can have another server that's running that has another 500 queue runners. They can still talk, okay? Different queues use different methodologies to do it. Some just use simple APIs, but you can have multiple machines, so it scales very nicely. Long-running reports are a great task for queues. You can hand it off to a queue runner is going to pick it up, a queue runner is going to execute it. If it takes 5-10 minutes, however long it takes to run the report, and then package it up as a PDF or something like that and email it to the user, or email the user and say, here's a link where you can click and go view your report. Those are great ways to handle, or those are great ways to handle long-running reports like accounting reports and stuff like that. The best solution to the problem that we set out to solve. Well, we had several options. The first was just a big old zip file. Okay, when the user clicks send it, then we zip everything up, all the images up into one big zip file, make a call to the WordPress API, custom WordPress API endpoint that takes that zip file, uncompresses it, and inserts all of them into the WordPress system. You're not going to save a lot of time in the downloads because they're compressed, because most image formats are compressed these days anyhow, but you're only making one server call. So you do save on that. And that was one solution that we considered. Another one was a JavaScript marshaller. If we were going to have to do promises, we figured we might as well do it on the front end using JavaScript and write a marshaller on the front end, because while the user might up or put 5 images on there or 10 images at a time and then continue to write the story. Well, when they post or put it on the story, we can in the background go ahead and wrap it up in a promise and hand it off to the marshaller and say, go upload this to the server and give us back the connection information. That was a solution, but that's really not a trivial piece of code to write and maintain. Will allow the client to continue to work and not have to wait till all the files are uploaded. Sometimes, though, the best answer is just to change the workflow. In this case, since they were publishing big posts from the client side on the back end to the production server, why not let the client tinker all they want, and then once they're ready to go, put a publish button on the screen, they click that button, and it pops up a window and says, go get a cup of coffee, because this is going to take a while. And that was the best of all solutions. We just had to explain to the client, hey, look, this is the best way to handle this particular problem. But along the way, we learned an awful lot about promises, and that team is using Guzzle promises. They do a lot of back-end WordPress programming. They're using Guzzle promises to do all kind of fun stuff now with the WordPress API, making calls to the REST API. Hey, I want to thank you for your time. It has been my great pleasure to present this to you. If anybody's got any questions, I'm happy to answer any.
That was a great talk. Do you have the code available to kind of peek at?
Yeah, I got to upload it, but Josh, I will send you a URL. It's up on GitLab, on my GitLab account, gitlab.com/CalEvans. But the coin flipper isn't there, Schrodinger's coin. I just finished that up about an hour ago. So I want to, let me upload that and I'll send it over to you.
Awesome. Anybody have any questions? Cool. Well, it looks like I love the peek into the future too, and I'm really excited for PHP 8 and all that great stuff. That's going to be another huge jump for us. So okay. I appreciate your time, and thanks again. Great talk, Cal.
Thank you so much. Oh, some people have been saying things. Oh, they just think. Okay, not a problem. I'm around on Twitter if anybody needs me. I'm gonna mute myself now, and y'all can take it over from me.
Sweet. All right. So next up, we've got Cody Moss. He's going to be covering Helm. Cody, let me see if I can find you here. Can you share your screen? There he is. Cool. So yeah, just again, thanks, Cal. That was an awesome talk. Definitely check out Nomad and a lot of the other cool projects he's involved in as well. Cody, I've known for a while myself. Great developer, as well as more going into the DevOps stuff now and becoming a ninja at that as well. And I'm kind of a noob when it comes to Helm, so I'm excited for this talk, Cody. I don't think we can hear you.
There we
go.
Mute buttons. You have to remember it, because not just software.
It happens.
But yeah, so welcome everyone. This is my talk about engineering at the Helm. So what I'm going to be covering today is Helm. Well, let's go ahead and actually have the window active so my buttons will work. So first of all, my name's Cody. I'm a system engineer DevOps over at Slick Deals. There's all my contact information. You can find me on Discord, Twitter. I'm also on Facebook every now and again if you really want to hit me up there. There's my GitHub. All the code examples except for one of them that I finished just yesterday will be up there, and I will for sure add them to the links with the slides. Okay, so what is Helm? Well, I heard something fairly recently, and I really like the term, but it's Kubernetes is like installing Linux 20 years ago. But now with things like Helm coming out, I feel like it's more like 15 or 10 years ago. But so Helm is a package manager for Kubernetes. And because when you're trying to get your application onto Kubernetes, there's a mass amount of configuration files that you have to manage. And if you're managing all of those by hand, sometimes things can get fuzzy. Also, if you want to like have certain logic for things, it can get real complicated real quick. Helm comes in to try to solve that problem. And the fact is that it kind of came in and has a whole system that it has, and it's also building an ecosystem around itself, because you can set up like repos and other things for people to be able to pull down your packages, but you can also use the system yourself to set up packages so that you can deploy them more easily to Kubernetes. So just a couple more things that I have to cover is if you're using kubectl, it honors the kube config file and the kube config environment variable. So if you're trying to set up Helm, that's all you need to do is just have your kube configuration on your box and Helm installed, and it will work right out of the box for you. Okay, so they call their packages charts. And it's another play, like basically everything in Helm is based on like C names and stuff like that. So if you're familiar with like chef being everything in a kitchen, Helm is everything of the C. So in this case, we have a chart that's supposed to show how to install your applications onto the cluster. It's basically YAML templating with logic. You can variabilize your deployments. You can give it parameters. You can also make files that will say, hey, here's the configuration. And based on that configuration, it'll add certain things, take away certain things. Like you could have it so that you'll be like, if ingress is enabled, I want you to set up an ingress object. But maybe not everyone has ingress set up. So I can have it be ingress is false, but node port is true, and I can actually have the user give me what port they want that exposed on. We'll actually see a demo of a little bit of that, but not to too much extent. You can, and then what's also kind of funny is, or well, something that's also kind of relevant to like things like Composer or other package managers that are in Linux distributions is the fact is that you can form what chart dependencies. So these chart dependencies can just be like, I want Prometheus installed, and here's my configuration on top of Prometheus. Or I can actually, with Helm 3, there's this new, like people were kind of playing with the idea, but there's now charts that exist just to supplement other charts called library charts. I don't have a working example of that yet, but maybe in the future, I will definitely send that out over on my GitHub. So keep an eye out for that. Chart.yaml file or charts can be pulled down from the network or internet, or you can run them straight off of your local box. They don't have to be out on the internet. They don't have to be up on a server. Like when I do my Helm chart install, it could be right off. Like you just have to point it at a chart on your local system. So this is going to be the first demo. And let's go ahead and take a look at it. And now I have to find my application window. Okay. So, can everyone see my screen, my terminal, and is it too small?
Your tiny, tiny screen.
It looks like you're on like an old CRT square ratio screen.
Well, here, we'll solve that.
There we
How's
go.
that?
Oh, whoa. Zoom in just a little bit on the text, and I think we're good.
Yeah, sorry. 4K screens are killer.
This is all
Okay, how's that?
perfect.
Okay. So This is my Helm chart. We'll go over it in a code editor here shortly. So you don't actually have to worry about all that. So first, in order for me to do this, I need to have a Kubernetes cluster set up. So this is one of my favorite distributions, one of my favorite tools called K3D, and it installs K3S basically in Docker, so you can run it locally. So I'm going to export that.